I want to show you how character encoding works. So I'm going to create a file, Latin1, going to set the encoding. This is Vim, it's a command line text editor. You don't need to know how it works. But here I'm setting the encoding to Latin1. Okay, Latin1 is the same as ISO 591. Okay, we have seen this chart set, this character set before. So I will write an A to a file. I'm going to open it in a text editor, to an hexadecimal editor. And we can see that here the character A has been codified as a 61, and this is the new line character that the text editor adds at the end of the file. Okay, now I'm going to use a different codification. Vim UTF-A. I need to change the encoding. UTF-A. I will write a name, and here edit UTF-A. Remember that here, if we check the Unicode table, the code point for the A lowercase a letter is 61. And if we see what is in the file, we have a single byte, sorry, a single byte for the character 61, and it corresponds to the code point of the letter. It's the same codification as ISO 8859, but it was done on purpose to be compatible with most of the existing text files. Okay, but now I'm going to change, I will create a new file using another codification, UTF-16. I will write an A here, set file encoding to UTF-16, write the file, and here we can see how the contents have changed for that codification. Remember that UTF-16 uses a minimum of 2 bytes for each char, and those are the chars corresponding to the A, and those are the chars corresponding to the new line. In this case, we have multiplied the size of the file by 2. And if we use UTF-32, I'm going to write an A, 32, write the file, and edit the file. Now we have 4 bytes for each character. Okay, this corresponds to the A, and this corresponds to the new line. So we have 4 times more information than with the UTF-8 codification. Now I wanna show you what happens if we try to codify a character that it is not in the basic ASCII table. So I will use the UTF-A version and to exit here, and I will write a Cherokee character. For example, I don't know, this one. If I write this to the text editor, set file encoding just in case. If I write this to the file, take a look that we are using Cherokee characters in the computer. That was very, very difficult before Unicode. So if I open this, we can see that we have used 3 bytes for representing the Cherokee character. This is the new line. We need just a single character for the new line. But now the Cherokee will use 3 bytes. And what happens if we encode this file, we encode this character using UTF-16. Okay, so I will open the UTF-16, write the Cherokee character, set file encoding, F16, write the file, and let's see what is in the file. Okay, this time the Cherokee char has used only 2 bytes, and the new line has used 2 bytes. So if our text was mostly composed of Cherokee characters, it will be most efficient to use UTF-16 because most of the char will use only 2 bytes. If we had used UTF-8, the Cherokee characters will have used 3 bytes each one. So that's why it's important to choose the right Unicode codification when storing your text data.